Hi, and welcome to our lesson. Today we're going to start the first of two lessons concerning the measure of center and spread. And most of us are familiar with mean, median, and mode as measures of center. Our textbook does not give a whole lot of statistical weight to the mode, so we don't talk about it. However, we are going to refresh your minds a little bit about the mean and median. Now you know that the mean is the arithmetic average, that is, you add all the data elements in a set and then divide by the number of elements. We're all familiar with that. I'd like to share with you a formula that says that same thing. The symbol for the mean is x with a bar on top, so x bar is equal to, and then it is the summation symbol, since we have to add, that's the Greek letter sigma, the summation of all the x values, so sum of x's over n. N stands for the number of data items, x stands for an individual data item, and to find the average you add all the items and divide by n. And what that gives you is an idea about the numeric value that's in the middle of the set. Okay? The arithmetic mean is a numeric value, an average item, if you will. Some people call it the balance point. If you could cut this histogram right out of the screen and balance it on your finger, the mean would be the point that it balances on. The median, on the other hand, is not so much about value as it is a number's position in the set. Okay? The median is, well, you know the definition, the middle number in a data set, or the average of the two middle values, and if you think about that, if you're taking the average of two numbers, that might not even be a number in the data set, right? It's the middle number that's in the data set, or the average of the two middle. And then I know that's how you find it, but what it does, the median is the place that divides a data set into two equal pieces. Two equal size pieces. Where the average is about a numerical value, the median is really about position. Where a number is located in the set, either in the top half or the bottom half. Okay? To illustrate some properties of the mean and median, I'd like you to consider this. 5 third graders, all about 4 feet tall, it says, are standing together when their teacher, who's 6 feet tall, joins the group. Folks, that could have been my daughter's 5th grade teacher, Miss Rademacher. She was huge. Before she gets into the picture, there are 4 of them standing there, or 5 of them standing there, all about 4 feet tall. And if that's the case, then you know that the mean, or the arithmetic average, has to be 4. You'd add all those together and divide by 5, and you get 4. It's also true that the middle value in this data set is 4, so the median is also 4 here. As soon as the teacher joins the group, however, things change. So we still have our third graders here, all of them at 4 feet tall, and all of a sudden here's the teacher. So you think about that mean. Instead of 20, now we're at 26, divided by 6, it would be 6 people instead of 5. And that goes in there 4 with 2 left over. 2 6 is a third. So the mean went up by a third, adding that teacher's height. The median, however, the spot where the set is divided into equal pieces, is right here, and the median remains at 4. Now, I guess what that's supposed to remind us of is that the mean is more sensitive to extreme values. The mean is more sensitive to extreme values. It gets dragged up or dragged down based on smaller or larger numbers being added to the data set. We want to move on and next talk a little bit about measures of center. And today we're going to talk about 2 of them. The range of a data set, which is found by taking the maximum value minus the minimum. And really that tells you the range of values that are included, max minus min. The interquartile range of a data set is found by taking its third quartile minus its first quartile, and you'll recall that we talked about quartiles earlier in this class. If you find the median, then the quartiles are the medians of each half of the data set. And it does ask us to do that right here. Find the range, quartiles, and IQR for the ages of these workers at Westvaco, round 2 of the layoffs there. There are 10 items in the data set, so the median would be between the 5th and 6th values here. Again, we're going to end up here with a median that is not part of our data set. 55 and 48 divided by 2. That's 103 over 2, or 51 and a half. So our median is 51 and a half. The range of this data set is found by taking 64, the maximum value, minus 25, and that's going to give us 39. Telling someone, though, that you have a range of 39 is nowhere near as descriptive as saying that the ages ranged from 25 to 64. It's much more descriptive to give the end points, and then if you want, you could say that is a range of 39 years. The lower quartile will be the median of the lower end of the data set, and the number that divides that data set into 2 equal pieces is that 35. On the high end, the upper quartile or third quartile is 55. All of those values can be found for any data set that's in your TI calculator. Casio's also can give you mean, median, and they also do mode. I want to give you the calculator keystrokes to do that, and then we'll show you how it's done. If the data is in list 1 in your calculator, it is a stat, a right arrow to calc, and then choose option 1, which is one variable stats. One var stat, it's called. If your data is in list 1, then enter. I have those Westvaco ages in my list 1, and I will go ahead and demonstrate how to find those values. Stat, over to calc, one variable stat. Now my calculator, I have to tell it which list, so second and 1 gets me list 1. Yours may not have this menu. Leave frequency list alone. You want to use each number once and then calculate. The mean, as you can see, is 46.4. We, however, need the range and the quartiles. So of the 10 items in the set, that's what N shows you. We can arrow down past that. The arrow tells us that there's more stuff. We had a minimum of 25, and as we found before, quartiles of 35 and 55. There's our median. The 5-number summary is exactly those values, folks. It is the minimum of a data set, the first quartile, the median, the third quartile, and the maximum. And that 5-number summary is what you use to build a box plot. And some of you may have heard it called box and whiskers, which is fine. Box plot. If we're going to create a box plot for Westvaco, this is what we want to think about. We need a number line, an x-axis, and those ages range from 25 to 64. I'm going to start my note at 20, and I'm going to go by 10s to 70. So there's 30, 40, 50, there's 70. And our minimum is at 25. That's a whisker. The low end of the box is at 35. The median is 51 and a half. Some people do a dashed line. I do just for emphasis. The third quartile is 55. That's the top of the box. And finally, the maximum 64 gives us that upper whisker. You connect the whiskers to the box. And there you have it. Your calculator will also do a box plot. That is one of the statistical plots, so second and y equals. You get into plot 1 settings, and the type that you want to choose is box plot. You'll notice that there are 2. My recommendation is that you choose this one that has the little asterisks out to the side, because this box plot shows you outliers. I have it set up to look at my list 1, each item used once, and that's exactly what I want. Since it is a statistical plot, a zoom 9 will give you an OK window. And here's our box plot, and it looks very much like what we drew. All right, let's write those keystrokes down here for box plot. It was second, y equals. On the type line, my recommendation is that you choose the box plot that shows the outliers. So it has the little thingies at the end. That's called a modified box plot, and we're going to discuss how to make one of those here in just a moment. You know, it is often necessary to know whether or not we have outliers, since we know that extreme values change data sets. So by definition, folks, an outlier, there's a mathematical way to determine if you have one. An outlier is any number or any data value that is more than 1.5 times the IQR, either above the third quartile or below the first. Mathematically, a number is an outlier if it's less than the first quartile minus 1.5 times the IQR, or if it's greater than the third quartile plus 1.5 times the IQR. So we're going to do that with the data plot that's shown here, and I happen to have these in my calculator. These are average ages for some mammals that were printed from our book. I will show you, I have the data in my list 2 here. And what I want to do is find the 5-number summary, because I'm going to make that modified box plot. So it's stat, it's over to calc, it's choose one variable statistics. This time my data is in list 2, so I have to tell my calculator that. Here comes my 5-number summary. And I'm going to just write those values down here, separated by commas. So I have a 1, an 8, a 12, a 15, and a 41. That is a long-lived animal right there. The IQR is the difference between Q3 and Q1, so 15 minus 8, or 7. And since we're going to be finding outliers, it might not be a bad idea to just figure real quickly what 1.5 times of 7 is. And that is 10.5. Okay, to determine if we have an outlier, we're going to subtract 10.5 from the first quartile. That would be 8 minus 10.5. That's going to be a negative number, folks, negative 1.5. No animal lives negative 1.5 years, so that's meaningless to us. The third quartile is 15, and 15 plus 10.5, that is 25.5. And I believe, looking at the data, that we have 2 animals that live longer than that. This animal is 25, so it's all right, but this is 35 and this is 41. So to draw our modified box plot, folks, what you do is, you're still on a number line, so we're going to start out there. And we said the ages ranged from 1 to 4, from 1 to 40. I'm going to just go 0 to 40 by tens. So in a modified box plot, you show the outliers with stars, asterisks. So we have an outlier at 35. We have an outlier at 41. Then you draw the box plot the way that you normally would. Low whisker at 1, the bottom of the box at 8, median of 12, third quartile at 15, and then the upper whisker is not 41 anymore. Instead, it's the next lower number before your outliers. So 25 becomes that upper whisker, and I'll finish my box plot this way. Very good. That is the end of our lesson today. So I'm going to ask you to go out and get that U-Try, and we'll talk about this in school.